Hi, welcome back to the Gapsters channel. A lot of people have been asking me what is the best power supply to use. So I went and measured a whole bunch of power supplies. I'm going to measure basically the ripple on these power supplies. Now ripple isn't everything. There's also internal impedance and other things, but it is one of the big ones. So let's check things out. So let's measure a few power supplies. So what do we have here? I've got here in the tin can here, just trying to be testing it. This is an interesting power supply from AliExpress. It can do dual voltage, so it'll do like +5, -5 volt at the same time. This is based on the Sigma 22, and if you are getting these, they come in two sizes of transformers, 15 VA and 25 VA. They also come in different types of transformers, a Beginzi transformer and a Talima transformer. Next, beside it, we have Ian Canada's Linear Pi. This is the dual version. And again, we're going to test that one out. Beside it, there is another power supply. This one is from Zero Zone. It's also based on the Sigma 22. And this is more geared for more amplifiers, so it can do a little bit higher current. But nevertheless, we thought we'll try it out. And this is another one as well here, based on the Studer 900. We're gonna try it as well. On the commercial side, we have a power supply here. This is the Shanti dual ultra noise linear power supply. We're gonna try this one out as well. We're also gonna test this HiFi power supply that you can actually buy from 5 volt to 15 volts. Now this is not a linear power supply, so this is a different category, but I thought I'll throw it in because quite a few people have been using those. This one is an old favorite. I've featured this one before. It's a cheap control, a fan or a motor, and it's only $5. So I thought I'll throw it in. It's good to compare to it as well. Now, not only we're gonna check out the power supply, we're gonna see if we add like big ultra capacitors after them, would that improve things? Like these are the UC conditioners by Ian Canada, and they are supposed to make a big difference to the supply. And bear in mind that these not only reduce the ripple, these have a very low interior resistance that we call ESR, and that's what makes these a great addition to pretty much any power supply. And for those who don't want to dabble with dangerous ultracapacitors, this is my CRC filter that you can actually modify and make it your own. And we're just going to see if that makes a difference or not. And last but not least, we're going to consider those giant ultracapacitors running on Ian Canada's UC Pure. This is a Mark III. This is a system where it actually charges the ultracapacitors, and then once they're full, it disengages, and then they're running on their own. So this is probably one of the purest form of power supply. But is it? So let's check it out and test it as well. The setup. Most oscilloscopes sadly, they only could measure down to like 10 millivolts, so they're not really that accurate to go down to the microvolt levels. So what do I use? I use a sound card. This is by Focusrite. It has a very low noise floor. It is used for recording microphone, and so but you can use it for this purpose as well. What we're trying to do is amplify the ripple. The ripple is so low, we're measuring into microvolts, so we want to amplify it. So this is going to be amplifying that small tiny signal so we can actually measure it. Now, to keep the sound card safe, you have to make a little device here, and I'll show you towards the end of the video how you can make it yourself, costing you just about $5, maybe 10. Next, you're going to need a cookie tin, and these are easy to get thanks to our friends in Denmark. You need to put your equipment in a very contained area so you don't get external noise, and trust me, noise gets everywhere. When you're measuring down to a microvolt, it's everywhere. And for software, I use REW, R-E-W. And REW is a free software, or you can actually donate if you feel like it. And it's an extremely very useful software. Use it for designing speakers as well and all kind of stuff. REW has an RTA, like a spectrum analyzer feature, and that's going to be very handy for this purpose. Now, optionally, if you do have a signal generator, it's going to help you calibrate your Root software, because you need to tell Root, okay, this is 10 millivolts, so Root knows exactly what 10 millivolts is. You can calibrate it. If you don't have a signal generator, you can use any cheap signal generator that you can get. You can even use your iPhone if you need to. Before you start measuring, you need to really clean up everything. I had to actually move to a different room because where I usually work, there's so much equipment that there's so much noise. I had to move to our dining room here where there's very little noise. And so if you look at here, you could see this is 1 microvolt line, and we are way below that. So we are at least probably at 1/4 microvolt of noise level here. And to demonstrate, just touching the probe here with just my fingers, look how much noise that generates, about basically 1 millivolt, just touching it with my bare fingers. As soon as I take it off, it drops down again. If you don't know how to set up the software, how to build this little safety device, just stay tuned to the very end of the video. I'll talk a lot about that. But for now, we're going to start testing some of these power supplies. First power supply I'm testing in our Danish cookie jar here is the power supply from AliExpress, and this is based on Sigma 22 design. All right, so this is the noise floor before everything else. And I'm just going to plug it in and see what happens. There we go, just plugged it in. And right away you could see there is a little bit of noise, but to be honest, this is nothing. We are down here probably about 7 microvolts. We've got a little bit of 60 around maybe 4 microvolt, and a little bit of 180 around basically 6 or 7 microvolts there. And so that's about it, all the way up to 50 kilohertz. Now these are linear power supplies, so they're not going to make noise in the very high frequencies like some of the other digital ones. Now, just so you know which condition I'm testing on, these are all under a load, so under a small little light bulb here, incandescent light bulb, and it's drawing 135 milliamps. So this is kind of roughly what most of us are using those power supplies for. Just for comparison, I want you guys to see what a switching power supply is. This is just a generic power supply that you could get. I just picked one randomly, and I'm just going to give it a try. Okay, right away we've got a lot of things creeping up. We've got about almost 50 millivolts here around the 1K range, and we also have a little spike here in the 25K range. So at least I would say 50 millivolts. So there's a huge difference between switching power supplies and linear power supplies. Not all switching power supplies are bad. I'll tell you later, we're going to show you how they can actually be good as well. Next one we're going to try is another one of those Sigma 22 from AliExpress. This is the one that has the Talima transformer, and we're going to see if there is any difference. If you are using those, make sure that you have actually shorted the switch. If you don't short the switch, the transformer will not start. And make sure you don't actually electrify yourself, because the switch is actually using the high voltage. And also make sure you use a lot of paper or cardboard underneath it if you're using in a tin can, so you don't actually short the bottom of the board. Here we go again. We're still below the 1 microvolt level by far. We're going to plug it in. So this is using a 15 volt, and I'm not going to leave it too long because my thing is going to be frying. We're looking about 10 microvolt at the peak. Next, I've got the same Talima S22, same one by Express, but this was a 5 volt version to be on the fair side, and I just plugged it in. And let's have a look to see what we got. Yep, it looks about the same as the first one. You're looking around roughly 7 microvolt at the most, I would say. It's fair because when you have a 15 volt one, you're going to have a slightly more ripple noise because it's a higher voltage. So I would say they're all measuring pretty much the same. So I wouldn't bother paying more money for one power supply versus the other. I would go for the bigger one, like the green one that I have, the what called Beginzi. Seems to have a 12.5 VA times 2, so 25 VA. I found that would be probably a better value. It was a little bit more expensive though. Now, what would happen if I add a CRC filter like to this power supply? Because that's probably one of the common use of the CRC filter for people who are using those type of transformers. So I just plugged it in, and as you can see, the ripple has dropped quite a bit. So you're looking about probably 3 microvolts. So we dropped from 6, 7 microvolt to about 3 microvolts. So it's, I would say, it definitely made a difference. And this is in the configuration where only one of the jumpers are in. So J2 shorted, so basically it goes down to 2 micro ohm impedance, and that seems to help quite a bit. Next, I added Ian Canada's UC conditioner to the mix, and let's see how that behaves. Oh, here we go. Now you can see that actually it just dropped to just slightly below the 1 microvolt, so that's even better. And that's definitely, you can see that the more capacitance we're adding, the more we're actually bringing that ripple down. Now, these are like, when you talk 1 microvolt, we're talking like really record-breaking, basically, levels in ripple. I want to show you something. When I first plugged in the ultra capacitors, I had them sitting like this because I was hoping to get them in the box as much as possible. And check out what happens to the noise when they are in this position. And I was thinking, wow, this QC conditioner is not doing that great because the noise went higher than the original. Well, not much higher, but it's at least went back to 8 microvolt. And the reason why is because if you look at the capacitors, they're really close to the transformers. So just the transformer noise here is causing that extra ripple. So make sure you keep your stuff away from transformers. They do, even though they seem to be like isolated, as you can see, I'm just going to move it away. I'm just moving it right now as we speak. And just you could see how the noise level just dropped down just by moving those ultra capacitors away from the transformers. Next thing I've got here, and we're testing, is the Ian Canada Linear Pi. This is a dual version, and it's running on 5 volt mode here. And we've got beside it a transformer. This is from Trimagnetic. It's the medical grade transformer. And thanks again to our Danish friends with cookies and cookie tins, we were able to isolate the second transformer, trying to keep the noise as low as possible. So what do we get here? Let's have a look and see how that's looking. Well, this looks really good. We're really close to the 1 microvolt range. I would say about 2 microvolts, maybe 1.5. And Ian rates this one at 0.8 microvolts, so I'm not too far off, and I think I would say, yeah, that can be true. After all, my equipment, like I said, isn't the state-of-the-art equipment, but also at the same time, it's fairly accurate equipment because if I'm getting close to 1 microvolt means, and it is rated at 0.8, means both his rating is good and my equipment measuring is also good. So that's pretty good ripple for his power supply. Next, I added the ultra capacitors here in the mix, and to see on top of Ian Canada's linear Pi, because this is one of the common things that we end up using, those two in combination together. And let's have a look to see what happened after adding that. Well, it dropped significantly again. Let's focus a little bit on that. Here we go. So what we have here, wow. Now we have dropped for probably close to half a microvolt. Maybe 0.6, something like that. So that's really incredible, actually. That's probably the lowest achievement we have gotten so far during this test. Say kudos to Ian Canada and his stuff. I think it does work as he claims them to be. And for those that do not want to use the ultra capacitor, we're just using a little my CRC filter here, and we're just going to cover it up. And let's have a look if this does anything to the ripple. And let's have a look. Yeah, there's a little bit of difference. Not as big as the ultra capacitors, of course, but you could see we dropped down to probably 0.8 of a microvolt versus before we were about 1.5 or so. So it dropped down a reasonable amount, like I said, but not as good as the ultra capacitor. But it's a decent thing to use if you do not want to use ultra capacitor. Now bear in mind, this is just a simple design. You can go get the schematics and change it up, maybe add 50 capacitors or whatever. You can make it a lot bigger or a lot smaller. Next, what do we have here in our Danish cookie tin? We have the board that is basically an imitation of the Studer 900. And again, this is from AliExpress. And let's have a look to see how this one behaves. All right, we've got a really good one here. We've got a little bit, there's no major spikes anywhere, but there's a little bit some higher creeping noise on the higher frequency level. Not by much, we're still below the 0 point, I would say close to 0.8 and 0.9 microvolt. There's kind of spiking a little bit. But other than that, it's pretty darn clean. I did not expect that from this board. So yeah, this is actually a pretty good one for what it is. Now this one is not a +5, -5 kind of design, but there are two individual 5 volts and they are quite individual. I tested the ground, they do not touch, they do not connect, the two grounds do not connect together. So you just have to swap one of them, connect the positive to the ground and create your own 0 plus and -5 volt if you desire so. Here I added the UC Pure by Ian Canada to the Studer 900, so basically using those two ultra capacitors. And let's have a look to see how that behaved on the chart here. All right, so what do we have here? Well, we've got, that's a pretty nice ripple. We are basically close to 0.6 of a microvolt, fairly similar to what we did with the linear pi and the UC conditioner. And definitely brought everything down, even at the higher level here. Those that were creeping up almost to the close to 1 microvolt before they went down quite a bit. It's all around it cleaned up really nicely. So I think those UC conditioners, I think that's a really good addition to any power supply. And adding the CRC filter here, let's have a look at that. Oh, it's a little bit better, not as good as the ultra capacitors. These are creeping a little bit slightly in the 0.7, 0.8, but you know, it's still a little bit better than bare. It's actually not much, but I think at this level, they're all pretty good. Once you're down below 1 microvolt, you're doing good. Next thing, we've got this big board by Zero Zone. This is obviously meant to handle a little bit of a heavier load, and it says the Sigma 22 regulated PSU, so version 2.0. So let's have a look and let's see how it behaves. All right, let's plug it in and see what happens. I'm discovering this just like you guys. Wow, this has a lot of ripple. It's about 500 millivolts and there's a lot of peaks, so definitely not in the same league as the other ones. Next, we've got the HiFi power supply. This is the X and the 15 volt version. This is a switching power supply, which is supposed to be a lot better than most regular switching power supplies. The ripple is all staying just slightly over the 1 microvolt level. It's bouncing a little bit up and down, but it's staying well below probably 2 or 3 microvolts. So this is pretty good. And here using a CRC filter with the HiFi X, and let's see what we got here. Pretty much staying below the 1, just at the edge of the 1 microvolt level. So we went down a little bit. So it cleaned up a little bit nicer with the CRC filter. Now keep in mind you cannot use a UC conditioner with the 15 volt power supply because they only come with 3.3 and 5 volt max. So your CRC filter is probably going to be your best bet here for something like that. Next one we have here, thinking commercial, is the Shanti power supply. This is a big power supply, and as you can see here, and let's see how this one behaves. Let's see what's this one that the Alo Shanti does. So here we go. Looks not too bad, a little bit. See about a ripple bouncing up and down about 4 or 5 microvolts, sometimes a little higher. Overall, the rest of the frequency looks really good. The Alo Shanti comes with a really long cable. I wish it was a bit shorter, but that could probably what's catching some of the noise. So I added a CRC filter. Let's see, that will help it quite a bit. Let's have a look if that's the case. And let's have a look at that. And yep, right away we definitely can see a good difference here. You can see that it's more like close to the 1 microvolt now, which is really good in line of what its specs should be. So if you do have one of those power supplies, the power supply is really good, just that long skinny cable isn't that great. So maybe either shorten it or put a bigger one or bring it closer to what you needed, and then you'll be good. Or just add like a few capacitors down the road, down the line, and that should help it quite a bit. Next, we got the cheap eBay little regulator that's $5 only. It's basically a fan control unit, but it works great as a regulator. I have featured it on one of my videos. If you're interested in this one, look up some of my old videos. I'll put a link to it in the description. What it is, you can adjust the voltage here. You could see so I got it here set for 5 volts. So here it is. We're looking roughly around, I would say 5-6 microvolts here in ripple. That's not too bad for a $5 power supply. This thing even have a rectifier, so we're actually feeding it here with 12 volt transformer so because it has its own rectifier circuit as well. If you are going to go this cheap, I would say maybe a CRC filter. You can make that yourself very quickly and add a few capacitors, and let's see if that makes a difference. And here we go with the CRC filter. Got a little bit lower. We're down to like about 3 microvolts. All right, and the last one we are testing is probably what you most been waiting for, is these big ultra capacitors running on Ian Canada's UC Pure Mark III. The ultra capacitors alone are great, but you need still a system to charge them. And most importantly, you need a system to charge them and then let go. So when they're running purely on themselves and not connected to the grid. Now I'm only testing one bank here, which is a 5 volt bank, and it's running on a transformer. And the output, I wanted to simulate the way we usually do our output. So I have a 1 foot long basically twisted wire going into the test pen. I didn't even put the lid on in here because it's kind of a tough one, didn't want to short anything. So let's see how this thing performs. All right, so let's zoom in here. All right, so this is running super low. This is the lowest I've seen. This is basically lower than what my test unit here can measure. I cannot measure, my base noise is that. So it's basically below my base noise. We don't know how much, but it's definitely less than half a microvolt. That's for sure, because that's what my testing equipment noise level is. So remember, we cannot measure below your own test measuring device. But so this is exceptional, and we all anticipated probably this result, but you never know till you actually test it to make sure it is what it is. So yes, these are the king of basically power supplies. A combination of two big power supplies. The reason we use two, because for 5 volts they are only rated for 3 volts each, so you need to put them in series, and you need the UC Pure Mark III by Ian Canada to run those properly and to be running them as safely as possible. Bear in mind, using ultra capacitors could be very dangerous. If I short those wires, you can get 800 or 8000 amps, I believe. Something crazy amount of amperage. It's just going to fry your wires right away, and they could burn. Now, these particular wires don't burst into flames, so make sure you choose wires that are really have a very good flammable rating. I did a video about safety into those, but again, you have to do your own diligence, because ultra capacitors can burn your house and your neighborhood. Other than that, from a power supply point of view, you cannot beat an ultracapacitor power supply like that. It's just hands down probably one of the best you can get. So I'm going to post in a separate video how you can actually build your own rig, how to connect these, how to make the software run properly, do all the settings in the software, how to build this little safety device to make sure you do not fry your sound card, especially if you're measuring ripple on, let's say, a power supply for a tube amplifier. You're going to be testing 400 volts, so you got to be safe and ground and stuff like that. So it'll be a separate video just like about this coming up soon. Here you can see the big mess I created just testing all these power supplies, and there's just so many of them. That was quite a big feat actually doing this video. All right, conclusion. So these all measurements are based off the power supplies I have. There's hundreds of different power supplies out there in the world, but I cannot buy them all with my limited budget. And also it's hard to basically source all these things. So if you have your own power supply, you feel free to test it yourself. Like I said, my next video I'll show you exactly how to do that for roughly a couple $100. But you can feel free to send me one of those power supplies if you have one you're trying, if it's a company, and I'll gladly test it and with my limited testing equipment and show you. Also, these are based on the units I have. You could have that same unit in a different, measuring completely differently. It's possible. I may have had a bad apple here or there. Also, these are, some of them are imitation of some reputable companies. Sometimes you feel like this is not really the actual product, so the actual product could basically be way better than what these companies are doing with them. So take all this with a grain of salt. The whole purpose of the video is to basically test some cheap power supplies and see which ones handle better. Again, this is not a complete test. It's not fully covers everything. And my equipment, like I said, is not, this is not $20,000 precision equipment. So conclusion, what do we get here? It seems like the best power supply based on my tests is hands down those big ultra capacitors powered by the UC Pure Mark III by Ian Canada. It seems to be the magic combination. You cannot go better than this. If you want to go next, if you want to use something else, it seems like no matter what you use, if you add those UC conditioners by in Canada, it also seems to bring down things significantly lower and adds a really good, makes a decent power supply even better. If you don't want to use now ultra capacitors and you want to bring the ripples down a little bit, just use some small little capacitors, kind of like the CRC filter. It seems to help a little bit. Now, let's say you do not want to use any of these ultra capacitors. It seems to be you just want to use a linear power supply. And it seems based on the test that there's a couple that stood out here is the Studer 900, or the imitation of the Studer 900, shall we say, and the Ian Canada linear pi. Both those two were very close neck and neck, and provided some really close ripple on the bottom end. Coupled with the UC conditioner, they both did very well. Seems like now the linear pi by Incan is specifically designed for those, so maybe that could be the better way to go here, because they do stack nicely on top of each other. But again, if cost isn't very important for you, the Studer 900 did exceptionally well. Please keep in mind that ripple is just one of the factors that make a power supply a good one. There are so many other factors that you might want to consider. I'm going to list a whole bunch just on the screen here quickly. I'm putting in the corner here a video about my Gapster TD1 DAC, and that's what created all this fuel of these power supplies, trying to power it with the best power supply possible. On this corner, there's going to be a different video. It will change over time. It'll be a speaker in the middle if you'd like to subscribe to the channel. And please try to support me on my Patreon. It will help me buy more equipment, more power supplies, and test even more things for you. Take care, and I hope to see you again.